Hi, I'm Paul Battaglia, and this is section 4.5, the net change theorem. Now, right away in section 4.5, you'll notice on the first page of this section, we have the description of what the net change theorem is, but we also have an exploration on the side. And I actually think that I would start with the exploration in my class. So it's very simple. We just give the students some very basic information about a car traveling on a highway at a constant speed of about 65 miles per hour. And we ask them some very easy questions, at least introductory questions. How far has the car traveled in 2 hours? And most students don't have a problem finding this out. But then we graduate to more difficult questions, and eventually we end the exploration looking at, well, what if this car wasn't traveling at a constant velocity, and instead its velocity was modeled by the given function? What would change now? You'd be surprised how many students actually can figure out that if they just integrate that function from the time period specified, they could actually find the total distance traveled by the car. And so a great way to understand and help students understand this idea of what net change is all about. But then I think what's even better than that is getting students to understand that it's not always about particle motion. And the first example does that. We talk just specifically about something that doesn't have anything to do with velocity or acceleration, but instead the rate at which something is occurring, and how if we were to integrate that rate over time, we would find out how much of a certain quantity has accumulated. Now, given that, it's important to note here that units also play a very, very key role. In fact, on some free response questions, students are awarded 1 point sometimes for using the correct units. So what do we want to make sure that our students see? Well, we want to make sure that they can connect the idea that if you take a rate, let's say miles per hour, or gallons per minute, and you multiply that times hours, minutes, whatever it might be, then that unit comes out as miles or gallons, the accumulation. Really important concept to make sure students grasp. Now, there's a common misconception we need to address when we talk about the net change theorem, and that is that this idea of that the area under the curve is always positive. And simply it's not. So what I always like to do is I like to kind of play out for my students in class, what if I was in that car? We all assume that we just went in that one direction, but what if we went backwards? Well, in that case, our total distance would be impacted. So very simple. If I walk forward for 2 minutes and backward for 1 minute, even if it's at the same rate, the total distance traveled, not exactly what you might think, okay? The total distance is easy to find, but maybe not mathematically. So what we want our students to understand here is that if the area is underneath the x-axis, there's negative area, then that influences the accumulation of our function over time. So very important that students look at that. There's a great exercise, how do you see it, is the way it's titled, in this section that will allow students to kind of explore this, and it'll allow you as the teacher to see if they can catch it. I hope these tips have been helpful, that you find much success in section 4.5.